In section 1.3, collinearity between us and assumptions, we're going to start with a couple definitions. The first one is collinear points. They are points that lie on the same line. Now, the first thing that we'll talk about with those is that one point will always be between two other points. The second thing we'll talk about when we talk about collinear points is that if we have 3 points, two of the distances will add to the third. And we can take a look at that in the first diagram. If I have 3 points, we'll notice that one will always be between the other two. But we'll also see that two of the distances, when they add up, will always equal the greater one. Now the second definition we're going to talk about is non-collinear, and those are points that do not lie on the same line. Again, if we're talking about 3 points that are non-collinear, doesn't matter where they are, those 3 points will always create a triangle. So 3 non-collinear points will give you a triangle. But what we also know about these is kind of the opposite of collinear points, that two distances do not necessarily equal the third, and we can't say one point is between the others. Now let's talk about assumptions in the diagram. There are 4 major assumptions we can assume when we're looking at a diagram. The first is straight lines and angles. The second is collinearity. The third is relative positions of points. And the final one is betweenness. Now, the other thing that's really important are things you cannot assume from diagrams. The first thing you can't assume from diagrams are right angles. You cannot assume congruent angles or segments. And you cannot assume relative sizes of segments and angles. Now take a look at the following diagram. Pause this video and write down 3 things you assume and 3 things you cannot assume from the following. Some things that you can assume is that X is between points T and U. You can also assume that the W is a straight line, TU is a straight line, and SR is a straight line. Some things you cannot assume is that RXU is a right angle, TXS is a right angle, TXR is a right angle, or SXU is a right angle. Another thing you cannot assume is that X is a midpoint. Although it appears it might be, we do not know if those two distances are equal. Therefore, we can assume it's between T and U, but not as a midpoint. In this first example, we're going to draw a diagram in which point F is between A and E, and F is also between R and S. But we have to make sure that A, E, R, and S are non-collinear. So the first thing we're going to take is point F and make sure it is between A and E. And to be between the 2 points, they need to be collinear. We also know that F is between R and S, so that those 3 points would have to be collinear. But because of this last part saying that all 5 points are non-collinear, we got to make sure they are not on the same line. So we are going to put point R here and point S here. Now, it does not say that it is midpoint, therefore the segments don't need to be congruent. In the second example, we are given angle ABD equals 3x degrees, and angle DBC is x degrees. Now, what we can assume about the diagram is angle ABC is a straight line, and that BD is between angle ABC. Since it is a straight line, we know, or we can assume that angle ABC equals 180 degrees. We also know, or can assume, that angle ABD plus angle CBD equals the total angle ABC. Therefore, we can do some substitution. 3x plus x equals 180. 4x equals 180. X equals 45. Since x equals 45 and we're looking for ABD, 3 times 45 equals 135 degrees. In example 3, we're again given this diagram and given that angle DBC is a right angle. And the conclusion is, can we assume or conclude that angle ABC is obtuse? And would this be always, sometimes, or never? Well, if we are given that angle DBC is a right angle, and we can assume relativity of sizes, we can assume that ABC is larger than that, therefore it is obtuse, therefore this would be an always statement. And finally, in example 4, it says, given that F is between A and E, can we conclude that EF is congruent to FG? Well, we're given the relative statement that's between points E and G, therefore they're collinear, but we cannot assume that these are congruent. Now, they may be congruent, but it's not stated, but it is a possibility, and since it is a possibility, that would be sometimes.